Okay, this is the Unit 10 review. How many grams of KClO3 can be dissolved in 100 grams of water at 100 degrees Celsius? Okay, well, since we were looking at 100 grams of water, okay, we can use our curve. So let's take a look here, and we're going to find 100 degrees Celsius, and the curve I picked off the internet unfortunately only goes to 100 degrees Celsius. So we're going to go all the way up to KClO3, oops, which is right here, okay? Now, when you go over, it looks like it's 60, so the answer is 60 grams. Pretty easy, huh? Okay, what is the molarity of a solution made by dissolving 89.8 grams of NaCl in 500 milliliters of water? Okay, with this one, you're given a mass, and you're trying to find molarity. Well, we know molarity is moles per liter. So we have to convert that mass to moles first. So we're going to take 89.8 grams of NaCl, and we're going to divide it by 58.44, which is your grams per mole. So this is your molar mass. So you're going to take mass divided by molar mass to give you moles. And this gives you 1.5366 moles. Now we're going to divide that by 0.50 liters. Okay, so 500 milliliters is 0.500 liters. And then we get 3.07 molar NaCl. And guys, if you don't bring out your numbers far enough, you did 1.54 or 1.54 or 1.537, it doesn't matter, and you got 3.08 molar, you're still fine. You still got the right answer. What volume of ethanol is in 150 milliliters of a 50 proof solution? Okay, this one is a volume, percent by volume question. So we know that 50 proof, so 50 proof is 25%. Now we're looking for how much ethanol, which means we're looking for the amount of solute. So we're going to use the equation volume of solute over volume of solution equals percent over 100. Okay? So the volume of solute is what we're looking for. We're given 150 milliliters of our solution, and we're going to put 25 over 100. Now we're going to cross multiply, so it's 150 times 25 divided by 100, and that gives us 37.5 milliliters of ethanol. Okay, pretty easy, I think. If 25 grams of CO2 is dissolved in 1 liter of water at 1.15 atm, how much CO2 can be dissolved in 2.5 liters at 0.951 atm? Okay, this one's a Henry's law. Okay, you're given pressures, and when you're given pressures with solutions, it's Henry's law. So you have an S1, a P1, and an S2, and a P2. Now if you read the question, it is giving you 25 grams in 1 liter. Well, there's your S1, 25.0 grams per liter. And your pressure is 1.15 atm. And then it wants to know how much CO2 is dissolved in 2.5 liters. Well, first you got to find out how much is dissolved in 1 liter, and then we'll multiply it by 2.5. So we're looking for our S2, and we have 0.951 atm. Okay, so Henry's law is 25.0 divided by 1.15 equals S2 over 0.951. So S2 equals 25.0 times 0.951 all over 1.15. So S2 is going to equal 20.7 grams per liter. but it wants to know not this. So that would mean 20.7 grams of CO2 in 1 liter, but we don't want 1 liter. We want 2.5 liters. Okay, when we do that, we get 51.8 grams of CO2. Okay, pretty easy so far. What volume of water should be added to 45 milliliters of a 10.8 molar NaOH solution to make a 3.46 molar solution? So this is a dilution. Whenever you've got one molarity and it decreases, so you've got your M1, and basically your M1 is always the biggest one and your M2 is the smallest one. It's a dilution. Okay? So I'll let you continue on. Okay, so M1 is 10.8 molar. V1 was the 45.0 milliliters. Now it's asking how much water is added. That means we're going to be calculating the V2, but the V2 is the final solution amount. And then we're going to have to subtract what we initially had, because we want to know how much water to add to get to V2. So our M2 is 3.46 molar. So we have V2 equals, and it's M1 times V1 divided by M2. So this gives us 140 milliliters. Now, to find the amount of water, it's 140 minus 45, which is 95 milliliters of water added. Okay, and actually this should be 95.0. It's just 95 milliliters of water. Okay, how much NaCl can be made from the reaction of 245 milliliters of 3.6 molar NaOH? Ooh, solution stoic. Whenever you see the equation, it's a solution stoic question. Okay, you are actually given the milliliters and given the molarity. So you look at what the number you're given, not the molarity. You always ignore the molarity. That doesn't determine what type of an equation or what type of problem we're working with. We're starting out with a volume. So this is a volume to mass. Okay, so it's a volume to mass one. And when we do a volume to mass, first we have to find moles using the molarity and using the volume. So step 1 is 3.60 molar and 0.245 liters to give us 0.882 moles of NaOH. Now this number is what we put into our picket fence. So we got 0.882 moles of NaOH. Now, and when we look at this is our mole ratio. So it's 2 moles of NaOH to 2 moles of NaCl. And then 1 mole of NaCl has a mass of 58.44 grams. And we get 51.5 grams of NaCl. Okay, hopefully you get that. Ooh, another solution stoic. What volume of 3.68 molar NaOH is required to produce 98.6 grams of MgOH2, so of magnesium hydroxide? Okay, this one you're given a grams. Okay, as I said, we ignore the molarity for now. We can't use that to determine because it's in both types. So we're given a mass and it's asking for volume. So this is a mass to volume. Okay, so in the mass to volume, we have to start out with the mass and put it in the picket fence to find the moles. So it's 98.6 grams of MgOH2. And 1 mole of MgOH2 has a mass of 58.33 grams of MgOH2. And we use the mole ratio. Oops, nope, it's 2 moles of NaOH. And we get 3.381 moles of NaOH. That's step 1. Step 2, let's take the 3.381 moles divided by the molarity, and we get 0.919 liters, which is also 919 milliliters. Guys, you're going to have to be able to go back and forth between liters and milliliters, because I might have the answer. Because remember, I'm doing the same way as I did last unit, where I'm going to have the problem, a big old space for you to work it out, and then I'll have the choices at the bottom. Now, you can guess the choices all you want, but unless the work, I'm only grading the work. I'm not actually grading those choices. Those choices are there to help you figure out whether you've done it right or not. Okay? So, if your choice isn't down there, you've probably done it wrong. But you need to be able to go between liters and milliliters. Okay, how much KNO3 can be dissolved in 398 grams of water at 60 degrees Celsius? Okay, so this is another solubility curve one. So we're going to have, when we use the solubility curve, we can find out how much is in 100 grams, and we'll use that to figure out how much is in 358 or 398 grams. Oops. I would help if I would look at my number properly. Now, when we look at our curve, it's 90 grams of the KNO3 is dissolved in 100 grams of water, so we just have to calculate X. So it's 100 grams, whoops, sorry, I am not doing so well right now. Okay, so it's 90 grams times 398 grams divided by 100 grams. And this gives us 358 grams of KNO3. Simple as that. Okay, what is the percent by mass of a solution made by dissolving 184 grams of MgBr2, which is magnesium bromide, in 215 grams of water? Okay, this is an easy one. It's the percent by mass. So it's the mass of the solute, which is the MgBr, over the mass of the solution, which is both the water and the solute, times 100. So we have 184 over 399 grams. So it's a 46.1% by mass. Now this is 184, okay, plus 215. Okay, so hopefully you don't forget to do that. Other than that, that's pretty much it. This was the extent of the review for today. I would still make sure you know how to do all those problems on your aqueous solutions worksheet, as well as 10.46 to 10.48. Use those as your study guides. And I will see you tomorrow, and good luck on the test. Bye.